Alright, today we're going to be talking about how we can graph exponential equations. Before we can address that situation, we need to know what makes an equation exponential. Now, this one's pretty easy to remember because it sounds pretty cool. When x is in the exponent, it's exponential. So if we have any sort of equation that looks like this, y equals 2 to the power of x, or f of x equals 3 times 0.5 to the power of x, as long as that x is in the exponent, it's exponential. Now keep in mind, y equals x squared is quadratic because 2 is the exponent, so this is not exponential. Alright, so go ahead and pause the video and write down this parent function for exponential equations. F of x equals a times b to the x. Alright, so looking at this equation, we have f of x, which is the same thing as just saying y, equals a times b to the x. Now, a is going to be our initial value, or our starting value. B is going to be our multiplier, which is going to be very important, and x almost always stands for time. Okay, so here we have two examples. From these, we can identify both our initial value and our multiplier. Both of these are going to be very important for graphing it. So let's go ahead and give that a shot. All right. All right, so the initial value is pretty simple. Our initial value is just our y-intercept. Okay, so initial value is the same thing as the y-intercept. So we see here that our y-intercept is 1, 2, 3, 4. Now from there, we know that we have a multiplier of 2. So all we're going to do is we're going to multiply to find the next number. So we have 4 as our y-intercept. When we multiply that times 2, we get 8. So for our next point at 1, we're going to go up to 1, 2, 3, 4, 5, 6, 7, 8. Now we could do it again, and 8 times our multiplier of 2 is 16, but that doesn't fit on our graph. So we have to get a little bit creative. So we know to go this direction, we are multiplying by 2. So not surprisingly, to go backwards, we're going to divide by 2. So starting at our y-intercept of 4, dividing by 2, we get 2. Now we can keep going. 2 divided by 2 is 1. 1 divided by 2 is a half. Half divided by 2 is a fourth. And you'll start to see a pattern emerging. What we have down here is called an asymptote. So add this word to your notes. Asymptote. Okay? An asymptote is a line your graph approaches but never touches. So you'll see in this graph, we're going to keep dividing by 2 and dividing by 2 and dividing by 2. But if we're dividing something by 2, it's just going to keep getting smaller. It's never actually going to go away. So we have a horizontal asymptote at y equals 0. This is going to be true for all of our exponential equations in this class. When you get to algebra 2, that asymptote can move around. So let's go ahead and give our second graph a try. Just like our first graph, this is our initial value, which is also the y-intercept. So we're going to start our graph at 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1/2 is our new multiplier, so to go this way, I'm going to multiply by a half. So 8 times a half gives me 4. 4 times a half gives me 2. 2 times a half is 1. 1/2, 1/4. Keeps getting closer, so again we see that asymptote. To go backwards, we would divide by 1/2. And for those of you who remember last year, when we divide by a fraction, we can just multiply by the reciprocal. So we're technically just multiplying by 2. So I can take my y-intercept of 8, multiply by 2, and get 16. But again, that doesn't fit on my graph, so I'm just going to sketch this guy in. Now make sure when you graph this, your graph does not actually touch the x-axis, because on the x-axis, again, we have an asymptote. So it's getting closer, but never actually touches. Now, we have just graphed exponential growth and exponential decay. You guys have probably heard those words before. What we have on the left is considered growth, exponential growth. And on the right, we have exponential decay. So in growth, it's getting bigger, and in decay, it's getting smaller. All right, before we move on, let's just take a second to look at the domain and ranges of these graphs. The domain is all the way to the left to all the way to the right, so we see our graph continues to the left forever, and it continues to the right forever. So here we just have an all real numbers domain. Now the range is where it gets a little bit tricky. We see that it goes up forever, but where is the lowest it ever goes? Now we see our asymptote is getting closer and closer and closer to 0, but it never touches. So this is just going to be a round bracket. Same thing for this graph. It goes all the way to the left, all the way to the right. And the lowest it ever goes is 0. The highest it ever goes is infinity. So how can you tell, just straight from the equation, if it's going to be growth or decay? Go ahead and make a guess. Make a guess on how you could tell. All right, let's see the answer. Growth is when B, or our multiplier, is greater than 1. So if we're multiplying by 2 or 3 or 17 or 57, we are going to have exponential grow where our graph is getting bigger and bigger and bigger. Now decay is a little bit trickier. Decay happens when our B is smaller than 1. Okay, so that means some sort of fraction. So anything a half, a quarter, a third, 0.5, 0.75. That's when we're going to have decay where our graph gets smaller and smaller and smaller. Okay, so go ahead and add those to your notes. All right, we're going to practice 2 more graphing, then see a few odd cases, and then we're going to wrap this up. So we see in this one, 3 is our y-intercept. So we're going to go up to 1, 2, 3. To go to the right, we're going to multiply by 2. So 3 times 2 is 6. 6 times 2 is 12, if you want to throw that on there. To go backwards, we have to divide by 2. This is a little tricky because we're going to get a decimal, but that's okay. 3 divided by 2 is 1.5. Then from there, it gets a little trickier, so I just sketch it in, making sure to include that asymptote that my graph never touches. All right, for the second one, this one's a little tricky because we don't see our y-intercept. Now, if we don't see the y-intercept, we have to be smart and just realize there's a 1 out front. So my y-intercept is just 1. Now to go forward, I'm going to multiply times a half. So 1 times a half is a half. Then we get a fourth, and so on. To go this way, I divide by a half or multiply by 2 over 1, which is easier. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, and so on. Then we sketch our exponential decay in, making sure to include that asymptote. So let's see some even funkier situations. Okay, so they don't look funky at first glance, but let's go ahead and look at this one. We're going to start at 2. Then we're going to multiply times 1. 2 times 1 is 2. 2 times 1 is 2. 2 times 1 is 2. This graph is not exponential. This one is technically linear because 1 to the x is just, it's always going to be 1. It doesn't matter what you're raising the power to. So b, our multiplier, cannot equal 1. That's not okay. All right, let's look at our second odd case. Again, we know this one starts at 1, 2, 3. And we see 3 times 0 is 0. 0 times 0 is 0. 0 times 0 is 0, 0, 0. Same thing going backwards. Well, not so much because you can't divide by 0. So this graph is even weirder. It just looks like this. So that's not even linear. We don't even know what that is. So b cannot equal 0. Now let's look at the third case. In our third case, we're going to start at 0. That's our initial value. Now 0 times 2 is 0, and 0, and 0, and 0 times 0 is 0. So this one, again, It's just linear. So a cannot equal 0 if we want an exponential graph. So those are just some cool tricks to watch out for. You cannot have b equal to -1. You cannot have b equal to 0. You can't have a equal to 0. And while I'm not going to show this, b cannot be less than 0. That's going to be something even crazier. All right, well, you guys know everything you need to know to graph. So go ahead, pause the video, try these 2 examples, and be ready to graph some exponentials in class.